This is a recurrence relation. We're told the first term is 10, and then to get the next term, we basically square root the previous term. So, because we could let n equal to 1, for example, and then x2 would equal the square root of x1. And you could let n equal to 2, and then x3 is root x2, and so on. So you can see each time we're just square rooting the previous answer. So x2 is going to be the square root of 10. Now, on the answers, they're writing it in indices form, so I'm going to go with that and write it as 10 to the half. And then x3 would equal the square root of that. And what I'm doing then is actually, I could put the square root sign around it, but better, I think, to actually raise it to the power of a half. And we end up multiplying. So we get 10 to the quarter. And actually, every time I'm just going to be timesing the power by a half, because when I raise it to the power of a half, it's equivalent to that. Then I'll get 10 to the 1 over 8. Or maybe I write it as a half to the power of 3. That's going to be more useful when I want to find the 100th term, because x5 would equal 10 a half to the power of 4. And you can see every time I'm just timesing by an extra half, but that power on the half is always 1 less than the actual term number. So because actually the original one was 10 to the power of a half to the 0. So that means 10 to the 100, sorry, x to the 100 is going to equal a half to the power of 99. Now that's not there in the answers, so we just got to, that is correct, we just got to trust in that and modify it slightly. I can write a half as 2 to the minus 1, actually. So then it would be a half to the 2 to the minus 1 to the 99. And what I would do is multiply, let me write it like that. And then it's this that I would then raise to 99, and I would times those two powers together. So it's actually going to end up being 10 to the power of 2 to the minus 99. That is 1 over 99, 1 over 2 to the 99, which is exactly what that bit is there. So which means our answer is going to be C.